In problem 12, we're told today is Thursday. That is the fourth day, and it wants to know what day of the week we will be on 3 years and 34 days from now. So we're going to take day 4, and we're going to add to it 3 years, which is 3 times 365. There's no leap years. And then and 34 days, that's plus 34 days. So we have 365 times 3 plus 38 so we have 133 days, but we want to know what day of the week that lands on, so we're going to divide by 7 and take the remainder. That's how the modulus system works. The remainder is 6, so this number of days will land in this last column that is headed by a 6. And so the answer is Saturday. And that's a pretty surefire way of doing kind of an annoying problem. Problem 12 is sort of annoying. When we're working in mod 6, all the numbers that we know, all the natural numbers, are equivalent to one of these 6 numbers, 0 through 5. So the question is, what is 43 equivalent to? And the answer is we divide 6 into 43, the modulus into the number, and the remainder tells us the class. And so 43 mod 6 is congruent to 1. 55, we're actually trying to sort of solve an equation. What could this value be? We're not calling it x, but what could it be so that when we subtract 8, we get something that's congruent to 9 mod 12? Well, the things that are congruent to 9 mod 12, you can find them by adding and subtracting 12. So if we add 12, you'd get 21. If we add 12 again, you could get 33. You add 12 again, you could get 45. So these are all the numbers that are congruent to 9 mod 12. But you can subtract 12 from this to get this, and subtract 12 from 33 and get this, and subtract 12 from this and get 9. And if you subtract 12 from 9, you get negative 3. And I'm kind of interested in that. So let's temporarily think about this problem. What could you put here so that when you subtract 8, you get negative 3? And it would seem as if 5 does the job. And so I suspect that what we have is that a 5 is a number between 0 and 11 that we can put in here. There's lots of numbers we could put in here that work, but if it's in between 0 and 11, kind of the standard mod 12 numbers, I think 5 is going to do the job. Definitely 5. So 4 days at Longhorn, 3 days at the Meadows, 2 days of rest. I've numbered those, the first kind of week, so to speak, of work as 0 through 8, so I'm in mod 9. So we're told it's the first day of rest, so we're on this day 7. So day 7, part A says 30 days from today, so day 7 plus 30 would be 37 days. And I'm figuring out what the remainder is when we divide by 9, because this is modulus 9, and the remainder is 1, which is here, which means he'll be working at Longhorn. So A is Longhorn. B says 100 days from today, so that would be 7 plus 100, that's 107. 9 goes into 107 some amount of times. Looks like there's a remainder of 8. So that will be the second day of rest. So it's a rest day, or the second day of rest to be more specific. Part C says 366 days from today, so it's 7 plus 366. That's 373. Doesn't look much like a 3, does it? And so we have 373 divided by 9, because we're working modulo 9. We have a 4 here, and a 1 here, and a remainder of 4, so it will be the Meadows, the first day of working at the Meadows. So, the Meadows. Look at what the book cleverly did. They cleverly had one of each kind of answer. Imagine that.